Hi everyone, this is the video on section 4.3 in geometry, all about congruence postulates. In the last section we looked at triangles and if triangles are congruent or not, and realizing that we had to show that all three sides are congruent, corresponding sides, and all three corresponding angles were congruent in order to say one triangle is the exact same size and shape as another one. But that's a lot of work to do all three sides and all three angles. Is there an easier way? So today we're going to explore a couple different ways to make it easier in these two congruence postulates where you won't have to find all three sides and all three angles. So hopefully this will help. So let's get started. So let's say I am asked to construct a triangle that is congruent to this triangle. So I would get out my straight edge and my compass, which I cannot use with this board, unfortunately, but I'm going to try to pretend like I have those tools. And I would go about trying to do that. Well, let's say that I start by constructing this side, this bottom side. So I take my straight edge, I draw a long ray, and then I use my compass, and I measure this length, and I bring my compass down, and I mark that. Let's see. Yeah, that's pretty good. Mark that side as corresponding. So I've got that. Now I've got one side. So I think what I'll do is now I'll get my compass and I will construct an angle right here off this point that's congruent to that angle. And we've done this already. We've constructed congruent angles. So I'll take my compass. Let me get a different color so you can see what I'm doing. Take my compass, draw an arc, measure this distance, measure that distance, and then get my straight edge and do that angle. Right, okay, so now this side is congruent to this side. This angle is congruent to this angle. Well, this is nice. Now I can take my compass, open it to this setting, bring that over here, and put my mark there. That would make this side congruent with that. So I have this angle, and this side congruent. Sweet. Now, how many different triangles could I make? If this side is the same, this angle is the same, that side is the same, how many different triangles can I make now out of this? And you hopefully realize I have this point and this point that I have to connect. There's only one way to connect them. I just draw a straight line from here to here. All I need is my straight edge, right? Now I did this without the use of a compass, so you can see right off the bat that these are not congruent, but that process works. So really, I don't have to have this angle and that side. If I have two sides and the angle that creates them, the included angle, that's called the included angle. So I have two congruent sides and the included angle. So that's the angle that creates those two sides. Then that's all I need to know that the rest of the triangle has to exactly line up as well. Even though my picture isn't great because I didn't have a compass, I did it by sight. It was a sketch, not a construction. If you actually walked through this with a construction, you would see it. The fact that two congruent sides and their included angle being congruent is enough to show the entire triangle is congruent is called the side angle side congruence postulate. Side angle side in that order, either side angle side, or the other way, side angle side, angle side. These are all adjacent. That would be a lot to write in a proof, so usually it's just abbreviated SAS, which stands for side angle side. That is so much easier. Now all I need is two sides and one angle I don't have to have all three sides and all three angles. Okay, let's go through a similar process. I have this triangle. I want to construct a triangle that's congruent to this. So all three sides and all three angles have to be exactly the same. So I'm going to start the same way I did the last one. I'm going to start with this long side across the bottom. That looks simplest. Taking a straight edge, so I'll draw my straight edge, straight line, right? And now I'm going to use my compass to mark this length here, and I'll bring my compass down, and so I'll mark that off, and these two sides should be congruent. Now I'll do what I did last time too. I'll go ahead and construct an angle here that's congruent to this angle. So again, going through the same steps, I will use my compass to create an arc, measure this distance, and there is that angle. I hope. It looks a little bit big, but that's a rough sketch, not having a compass, but those are the steps that you would take. Now, instead of doing this side, I think I'm going to go to the other side of this line, right here, and I'm going to do the same thing. I'm going to construct an angle off of this that's congruent to that one. So I'll go through the same steps. I'll take my compass, create an arc, and from here, create an arc, measure this distance with my compass, measure this distance, and make a straight line. Now you can already see, can't you? And my angle is way too big, sorry about that. You can already see, can't you, if these two angles are the same and this side is the same, do I have any choice in the other two sides in the angle? There's only one way they can go, right? I'm creating this straight line and this straight line, and they're gonna meet right there no matter what. That's very similar to what happened before. I can only make one triangle. If I have a side and an angle on both ends, then I can only make one triangle. Therefore, all I need is two angles and the included side, don't I? So this is called the angle-side-angle congruence postulate, otherwise known as ASA, for angle-side-angle. Notice angle-side-angle, 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 those correspond. Therefore, you have the entire triangle. Again, I don't have to have all three angles or all three sides. Okay, let's look at this kind of situation here. I have two triangles, triangle ABC and triangle EDC, and I want to prove that they are congruent, and I only have the information that's given me in this diagram. What additional information do I need in order to say that one triangle is congruent to the other? What additional information would I need if I wanted to use side angle side? So if I wanted to use side angle side, then what other information do I need? Notice I have AC and EC are marked congruent. The other thing that isn't stated, but hopefully you should know, is that angle 1 and angle 2 are vertical angles. Therefore, they are congruent. So in order to use side angle side, what other piece would I need? What's missing? So you have side, you have angle, so I think what I need is the other side created by that angle, which is this side here. So I would need BC being congruent to DC. That's what I would need, and that's it. If I can show BC and DC are congruent, I've got the entire triangle using side angle side. What if I wanted to use angle side angle? Now what information do I need? Because I have these vertical angles and I have these sides, so what other angle would be enough to give me the entire triangle? And remember, it's angle side angle. So if we go from angle side then the next angle would be this one, angle E. Angle side, angle A. So we would need angle A is congruent to angle E. If we had that information, then we could use angle side, angle. Okay, I have the same triangle. What if I'm given that AB is congruent to ED? What if I'm told that? Is that enough? Can I say with that that the triangles are congruent? So I have two sides and the angle. So is the angle included between those two sides? And it is not. So if I go around, I have angle, side, side, or side, side, angle. Side, side, angle is not one of our postulates. I cannot use this. This is not enough. I can actually make several different triangles by changing these angles here in between. So that would not do it. The answer would be no. Side, side, angle is not a congruence. Here's a situation that you could run across. I have this diagram, and that's all I've been given, is this diagram. And I've been asked to prove that angle M is congruent to angle O. It's not shown that angle M is congruent to angle O, but if the two triangles are congruent to each other, then they would be corresponding angles. And so automatically, remember, corresponding parts of congruent triangles are congruent. So in order to do this, we need to prove the triangles are congruent. Do we have enough information? We have ML and OL, and we have angle MLN and angle OLN. That's given in the diagram. So our first step is always to list the givens. So I've listed the givens, and now I have a side and an angle. So I need either another angle, M and O, which I don't have, or how about another side? So I could use side, angle, side. Notice LN is shared by both triangles. That's my other side. So I'm going to say that LN is congruent to LN. Why do I bother to say that? Because I need that second side for my side, angle, side postulate. So let me list Ln is congruent to Ln. And do you remember the property that justifies that? Since it's congruent to itself, that's the reflexive property. So we list the reflexive property as our reasoning for that. Now we have side, angle, side. So now I can say the triangles are congruent. Make sure when you write your congruent statement, there's several different ways you can write it, but make sure that you write it in corresponding order. So I choose to say MLN is congruent to OLN in congruent order. My reasoning is side, angle, side. That's all. That's enough. For me, that's enough to say. Now, remember, that's not what it asked. It asked for me to say that angle M is congruent to angle O. Can I say that now? Yes, I can say that now because angle M and angle O are corresponding angles. So I would write angle M is congruent to angle O, and my justification, corresponding parts of congruent triangles are congruent, CPCTC, and I've done it. Okay, let's do some additional practice so you get an idea of how to use this. Can you determine if these two triangles are congruent using either side, angle, side, or angle, side, angle? So yes, and if so, which one? No, and why not? Pause, look it over, and then restart it and see if you got it right. Okay, hopefully you realized these are vertical angles. So yes, you can say these two triangles are congruent using angle, side, angle. Angle, side, angle. So the correct answer is angle, side, angle. Same question, different diagram. Can I show these two triangles are congruent? And if so, which postulate would I use? Pause it if you need to, or you may be able to see it right away. Okay, hopefully you saw side, angle, side, side, angle, side. So the correct answer for this is yes, using side, angle, side. Again, another diagram. Can I show these two triangles are congruent? Look it over, pause it if you need to, think about it, and then come back and check your answer. Hopefully you saw you do have these vertical angles, but that's all you have. You have these one angle and one side, and that side isn't even adjacent to that angle, so you cannot show that these two triangles are congruent. The answer for this one is neither one. It won't work. Here's another diagram. With this one, what I would like you to do is go ahead, and I'm going to tell you that these two triangles are congruent. I want you to write a congruent statement and the postulate or whatever that justifies it. So how do I know? How do you know? How do I know that I can say, yes, they're congruent, and write a correct congruent statement? So pause it if you need to, and come back and show me your answer. Okay, the congruent statement for this one can be tricky, so hopefully you are okay with it. It doesn't have to be exactly like mine, but make sure that in yours, R corresponds to M, and N corresponds to R here, which is weird, and A corresponds to C. If those things correspond to each other in your statement, then you got it right. Also, what's the postulate that you used? Side, angle, side, side, angle, side. You should have written side, angle, side. Okay, hopefully that was helpful in seeing how angle, side, angle, and side, angle, side work to show that triangles are congruent. And hopefully it's a relief that you don't have to do all three sides and all three angles. There are other ways to show triangles are congruent without having to do all of them. These are just the first two. We didn't practice a whole lot of proofs, but remember that corresponding parts of congruent triangles are CPCTC. Remember that can be helpful in proving things. If you can use side angle side or angle side angle to show the triangles are congruent, then all the corresponding parts automatically are congruent. So that's it for section 4.3, and I will see you guys next time. Bye for now.